Hey everyone, and welcome. Today, we are going to dive into some of the most common and, let's be honest, most frustrating problems in the DevOps world. We're talking about going from total chaos to being in complete control, and we'll do it by looking at some really elegant modern patterns for SREs. Let's get right into it. So, does this hit a little too close to home? You find secrets just sitting there in plain text in a pipeline? Or maybe you have to rebuild a dozen microservices just because you changed one line of code in one of them. These things aren't just little annoyances. They're huge risks and they waste so much time. But don't sweat it, because there is a much, much better way to handle all of this. Okay, first up, let's talk about something that's got to be the foundation of any solid CI/CD workflow: managing your secrets. You know what I'm talking about: API keys, database passwords, all that super sensitive info that should never, ever just be floating around in your code. This is a classic interview question, and there's a really good reason for it. How you answer this tells an interviewer a ton about whether you actually get security and best practices in DevOps. So let me ask you, how do you handle secrets in a YAML pipeline? And you can see the difference right here. On the left, we've got the insecure way, which is basically just tossing secrets into pipeline variables. The problem? They aren't version controlled, and pretty much anyone with access can see them or change them. That's just asking for trouble. But on the right, you see the secure way, using variable groups that are linked to something like Azure Key Vault. It's centralized, it's secure, and it's the right way to do it. And here's how you actually do it. It's a pretty simple 4-step process. First, all your secrets go into a secure vault. Then, you create what's called a variable group in your DevOps library. Step 3, you link that group to your vault. And finally, your pipeline just references that group to get the secrets it needs. That's it. No more secrets hiding in your code. All right, on to our next big challenge, the monorepo. It's a really popular way to structure code, but man, it can turn into a huge headache if you're not careful. The whole goal here is to build smart, not hard. And that means not doing a bunch of work you don't have to. So just so we're all on the same page, a monorepo is just one big source code repository that holds the code for a bunch of different projects. Usually you'll see this with microservices, where you have a folder for microservice A, a folder for B, and so on, all living together in one happy home. And that brings us to the million-dollar question. If you make a change inside the folder for microservice A, how do you make sure you only build and deploy microservice A? You absolutely do not want to trigger a rebuild for everything else. That's just a colossal waste of time and compute resources. Well, the solution is actually super elegant and powerful. It's something called path-based triggers. This is the magic that lets your CI/CD system be smart about which changes it should care about. So here's how it works. It's pretty simple, really. Each of your microservices gets its own pipeline, and then for each pipeline, you set up a trigger with a path filter. So the pipeline for microservice A is told, hey, you only run if there are changes inside the /microservice-A folder. A change to B's folder, A's pipeline doesn't even notice. It's efficient, it's clean, and it's exactly what you want. All right, let's tackle another super common problem: those out-of-control YAML files. When you have tons of pipelines that are all just slight variations of each other? It's time to bring in the don't repeat yourself principle, and we do that with templates. This quote really just says it all, doesn't it? The steps to deploy to your dev environment, your QA environment, and your prod environment are probably, 90% the same? So why are we rewriting all that code over and over again? That's where templates come in. And just look at the difference here. On the left is the before, a huge, fragile YAML file with tons of duplicated code. And on the right, the after, a short, clean little file that just calls a reusable template. It passes in the few things that are different for each environment, like maybe which secret from our variable group to use. It's just so much better. So what do we really gain from this? Well, first, templates are reusable. You define your logic once, and you can use it all over the place. Second, you can pass in parameters to customize them. Third, they are way easier to maintain. You change one template file, and boom, every pipeline that uses it is updated. And finally, less code just means fewer typos and fewer mistakes. It's a win all around. Okay, so we've built our code securely, we've deployed it efficiently, but now we need to know what's actually happening out there in the wild. And that brings us to the whole world of modern monitoring and observability. We need to be able to see inside our systems while they're running. When you think about a modern observability stack, it really has a few key layers. You've got metrics from tools like Prometheus, which tell you what is happening. CPU is at 80%, that kind of thing.
Then you have logging from systems like LK that tell you why it's happening by giving you the detailed story. APM tools give you a super deep look into how your app is performing. And of course, you need alerting to tell you when something's on fire. Now, if you're working in a Kubernetes world, there's really one name that comes up again and again for monitoring, and that's Prometheus. It has totally become the de facto standard for grabbing metrics from all your microservices and containers. And here's a super important little factoid you have to know about Prometheus. By default, it only keeps your data for 15 days. Now, that's totally fine for looking at what's happening right now. But if you want to see trends over, say, the last year, you're going to need to configure it for longer-term storage. It's a classic gotcha for new users. So Prometheus is definitely the king when it comes to metrics, but it's only one tool in our toolkit. Let's run through a quick cheat sheet of the other essential tools you'll need to get a full picture of your system's health. This table breaks it down really well. For metrics, you've got Prometheus, which goes out and scrapes or pulls data from different endpoints. For logging, you've got things like Splunk or the Elk stack to pull all your logs into one place. For that really deep performance analysis, you use APM tools like AppDynamics. And then to manage all the alerts, you use something like Alert Manager or PagerDuty to make sure the right person gets woken up at 3 a.m. So you might be thinking, okay, but how does Prometheus get data from my database or my Linux server? Great question. The answer is a little helper app called an exporter. Think of an exporter as a translator. It sits next to your database, reads its need of metrics, and then translates them into the language that Prometheus understands. And what about your own applications? Well, it's a similar idea. First, you add a little bit of code to your app to expose its own metrics on a web page, an HTTP endpoint. Then, inside Kubernetes, you create a special config called a service monitor. You can think of it like putting up a big sign in your cluster that points to your app and tells Prometheus, hey, come get your data over here. And just one last little deployment detail for you. Inside Kubernetes, you'll almost always see Prometheus running at something called a stateful set. That's just a fancy way of saying it's designed to handle important data that needs to stick around. And to keep things nice and organized, it usually lives in its own dedicated monitoring namespace, kind of like its own folder in the cluster. So there you have it. We've talked about secure secrets, smart builds, code that doesn't repeat itself, and modern monitoring. These are absolutely essential patterns for dealing with the complexity we face today. But it does leave us with one last question to chew on. As our systems get even more complex, what will be the next set of patterns we'll all need to learn to stay in control? Thanks for joining me.